Okay, so today we're doing naming compounds. So make sure you do the revision questions at the start of page 64. Have a go at those, and we'll go over the answers in a sec. If you haven't done it, just pause and do them. If not, let's go to the answers. So firstly, elements are substances made up of a single type of atom. Compounds are substances made up of two or more different elements chemically bonded. And mixtures of substances made up of two or more other substances together, or mixing them together, and can be homogeneous or heterogeneous. So remember, they're physically combined, they're not chemically combined. So for today's stuff, we just have to do a little bit more revision from year 10 and having a look at chemical formulas and some of the stuff associated with that. So firstly, compounds can be represented by their chemical formula. So you remember there's the atomic symbols on the periodic table. So when we combine them into a compound, we can write them as a formula. So sodium chloride is NaCl. Uh, Sometimes compounds contain more than one atom of a type, in which case we put the little 2 um, as a subscript to the right of that element. So in this case, here we've got H2O, it means that there's 2 hydrogens. Okay. Um, yeah, and because if there's a 1, we don't actually write the 1. So here oxygen's just got a 1, but again, that's implied. So we don't actually write the 1 just like in algebra. But if there's more than one, we write that number at the bottom right. Um, so some compounds contain what we call polyatomic ions. So really what they actually are a bunch of atoms covalently bound, but they exist as their own ion, and they can ionically bond. So these ions are made of several covalently bound atoms. So example, phosphate is PO4 with a 3 minus charge. Carbonate is CO3 and it has an overall 2 minus charge. And nitrate is NO3 with a single minus charge. So these ones are ones that you're going to have to remember with time. Okay, if you don't memorize it right now, that's okay, but we do need to get you to know these because they will be referenced a lot throughout the chemistry course. Now, if a single polyatomic ion is present in the formula, it's written as normal. So NaNO3 is sodium nitrate. But if we have 2 or more, we put them in brackets. So if we had aluminium carbonate, we put the carbonate here in brackets. Okay, so carbonate CO3, but we got 3 of them. Okay, so basically, again, just like algebra, that's 3 carbons and 3 times 3 oxygens. Okay, in that whole molecule. But we say it's 3 carbonates. Okay, so moving on to um, what we're doing today. So we're actually going to be starting to name the compounds based on the chemical formulas. So we just went over that bit of revision so you could actually know how the formulas are constructed, or some basics of it. We're going to do actual construction of formula in the next lesson, but we just need to be able to interpret the formula to get the name from it. Now, IUPAC, International Union of Pure and Applied Chemistry. This is a governing body that's responsible for naming conventions of compounds, amongst other things. Okay, so when we get to like organic chemistry and stuff, you'll hear about them again when we start having to name organic compounds. Pages and pages of rules for naming compounds. In the following slides, we've put together some of the naming conventions for mainly ionic compounds, but some basic binary covalent compounds as well. Okay, nothing too complex at this stage, but yeah. So naming ionic compounds. So ionic compounds always contain at least one positive ion and one negative ion. Now, they generally, but not always, contain a metal and a non-metal. There are a few cases where they don't, but generally it's going to be a metal and a non-metal. A case where it doesn't is things like HCl, HBr, a lot of our ionic acids, because technically hydrogen is not a metal. Okay, it's off doing its own weird things. Um, Now, in the chemical formula, the positive ions are always written first, followed by the negative. So, sodium chloride, sodium's got a positive charge, chlorine's got a negative. HBr, H is positive, bromine's negative. So on and so forth. So, to name the ionic compound, the first thing is to write down the cation that is present. So that's the positively charged one. So if it's NaCl, the cation is sodium. Then the anion's written down. So anion's negative. However, the ending of the name is changed to "ide." So e.g. chlorine becomes chloride. Sulfur becomes sulfide. Bromine becomes bromide, so on and so forth. There's a table of them in a couple of slides that we'll get to. Sorry, it's on the next slide. Just one thing to remember, if you ever get stuck on cations and anions, the easy way that I remember it is a lame way, but it's that cats are positive. Okay, so they've got pores, so they're positive. Kind of stupid, but there you go. Now, putting those things together, it gives us sodium chloride. Okay, so whenever we say sodium chloride, when we think of table salt, it's not sodium chlorine, it's chloride because it's the ion. So these are some of the elements and their associated anion. So chlorine becomes chloride, bromine, bromide, oxygen becomes oxide, nitrogen becomes nitride, phosphorus becomes phosphide. So this is important, especially in the next lesson when we have to differentiate nitrides from nitrates. Okay. Sorry, not in the next lesson, next slide. So if we have a polyatomic ion, we just keep that as it is. Okay, so we don't change it. It's just kept as is. So it doesn't become carbonide. It's still carbonate, still nitrate, still nitrite. Okay, these are the ones that you're going to have to remember because they're the ones that we come across the most often. There are plenty more polyatomic ions, but they're the ones that you're going to really come across a lot. Now, in ionic compounds, the prefixes mono, di, tri, we never use them. Okay, we never say magnesium dichloride, it's just magnesium chloride. Now, the reason for this is with ionic compounds, they go together in set ways so that we have a neutral charge. Covalent compounds, you can actually arrange them in different ways because they're sharing electrons, they're not actually giving them off or taking them in. So for example, with covalent, you can have nitrogen dioxide or dinitrogen oxide, and you need that di-tri naming convention there, but you don't need it for ionic. Okay, so these go into set patterns, and the actual patterns we'll look at next lesson. So ions that could have one of several different charges, mostly your transition metals, they have their charges stated in Roman numerals inside brackets. So for example, Fe2CO33 is iron 3 carbonate. So that means iron's got a 3 plus charge. But FeCO3 is iron 2 carbonate. Now, it is important for the naming as it affects the chemistry of the compound. So in the top one, you can see that there's 2 ions to 3 carbonates, but the bottom one, there's just 1 ion to 1 carbonate. Okay, so it is very important for the chemistry and a lot of that sort of stuff. Now, if you don't know how to find the charge, that's okay. You don't need to do it for this lesson, but you'll need to pay attention next lesson and then apply it backwards. Okay. So have a go at naming these compounds. So following that process that we just talked about, you write down the metal, you take the name of the anion, change it to "ide" and put that second. Unless it's a polyatomic ion, then you just leave it as is. So pause the video, have a go at answering those, and then we'll go through the answers. Okay, so firstly, NaF. So our metal, sodium. Our non-metal is fluorine, so it changes to fluoride. So we get sodium fluoride. We have magnesium as our metal, oxygen as our non-metal, so we get magnesium oxide. Next one's aluminium chloride. Now for this next one, you'll notice that we've got an NO3, so that's a polyatomic ion. Have a look on your table, that should be a nitrate, so it's sodium nitrate. Here's another polyatomic ion, SO4, which is sulfate, so this is barium sulfate. And lastly, we have iron 3 iodide. Okay, so we have iron as our metal, iodine as our non-metal, but it's iodide, so we change that. And because iron has a 3 plus charge, we put iron 3 iodide. Now, moving on to naming covalent compounds. So we have a bit of a different system due to the way that the bonds are formed. Basically, covalent compounds are generally formed between nonmetals. And so to name them, they're named in order of ascending electronegativity. So remember, basically, furthest to the left and furthest down is the lowest electronegativity, and it increases up towards fluorine. And then our noble gases have zero electronegativity because they're happy the way they are. Okay, so we always name basically from the left to the right on the periodic table. But you might need your electronegativity chart to get it 100% correct. Now, generally the elements, lower and further to the left are the more electropositive, so the ones higher and furthest to the right are the more electronegative. So we also have to use prefixes. So as I said before, we need to use that mono, di, tri sort of stuff, basically because it's, we can arrange them in different ways. So the ones that you'll need to know the most are mono, di, and tri. So mono is 1, di is 2, tri is 3. You may come across tetra a few times, that's 4. And then from there we use penta, hexa, hepta, octa, nona, deca. You probably won't come across those much at all, but at least remember these first 4. So those ones, whereas those are the ones that you really need to know. That tetra, not as common, but you will come across it. Now, the only exception to the prefix rule is when the first element has only one atom, so we don't write mono, that one's implied. So also compounds with common names, we'll use them instead. So H2O is always water, we never use dihydrogen monoxide. While it is technically correct, the molecule's named water, that's what we call it. The other one that we commonly use is ammonia instead of nitrogen. Was it trihydrogen nitride? So yeah, we do that. So following that, have a name the following compounds. So remember, we want to name the lowest electronegativity one first, follow it with the second one, and change it to iod. And make sure to put in your prefixes. Yeah, because they're definitely needed for this one. So pause the video, have a go at those 6 questions, and then we'll come back in a sec. Okay, so the first one, we've got a nitrogen and an oxygen. Nitrogen's the least electronegative, so one's going to go first. Oxygen will come second, and we'll have to change it to the oxide. So one becomes nitrogen monoxide. So we don't say mono-nitrogen monoxide, that's not right. We just skip that first mono, but we have to put in the second one. Why is that? Well, you can see down the bottom there's an NO2, so it's going to change that. Next, we have carbon and fluorine. Fluorine is the most electronegative atom, so that one's going to go second. So it's going to be carbon fluoride. Nitrogen's less electronegative than chlorine, so it's going to become nitrogen chloride. And sorry, these should be mono. So carbon monofluoride, nitrogen monochloride. Next, we have nitrogen oxygen. We have 2 nitrogens and a single oxygen, so this is going to become dinitrogen monoxide. Actually, I don't know why I started to write that in. There you go, dinitrogen monoxide, it's right there. Next we have, instead of 2 nitrogens and 1 oxygen, we've got 1 nitrogen and 2 oxygens. So this one's nitrogen dioxide. Remember, again, for the first one, we don't have to put in that mono. Now next we have 2 nitrogens and 4 oxygens. Now this one's dinitrogen tetroxide. Okay, so we have di, so 2 nitrogens, 4 oxygens. So, bit of a summary for today. Ionic compounds are usually made of a metal and non-metal. Again, it's not a hard and fast rule, just most of them are. The metal comes first, the non-metal is converted to the iode form. With covalent compounds, are usually both non-metals. The most electropositive atom comes first, and the other one becomes an iode. And we use prefixes to show how many there are of each. And again, we just ignore that first mono. Okay, so for whatever atom comes first, we don't bother with the mono if it's there, but we do need to put di or tri if there's more than one. Okay, so that's all for today. So please move on to the questions on page 67.